Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 6 in our incredible new tutorial series where you are knowing where you're going with our Ultimate GPS Tracker project. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And I will also need you to get out your GPS tracker project. I'll show mine here. And what I'll also need you to do is leave a comment down below to let me know how this project is going for you. First up, we soldered the header pins on the GPS module. Did that go okay for you? Did most of you guys get the pins on without damaging the GPS module? Leave a comment down below. Also, let me know how are things going for you as far as getting a fix and finding a place in your house where the GPS can see the satellites, can see the sky, and you have a fix, and at the same time you can be sitting at your computer working and writing your program, because you kind of sometimes need to be getting the program written as you have a fix. And then the third question is, have you guys actually gone in and tried the hot start, right? We've been doing the cold start where you just plug the GPS in, give it power, and then it can take 15 minutes, 30 minutes, an hour to really get a good fix. And I showed you there's that little battery holder that you can solder onto the back. You can put the little CR1220 battery in there, and then you can take the power off, put the power back on, and I'm finding I am getting a fix now with a hot start with just a few in just a few seconds. And so that certainly makes life a little bit easier. So let me know, give me some feedback, because as I'm making these videos, I need to know if you're just firing on all cylinders and everything is working, or if you are struggling a little bit to get things to work the way I am showing them. Because definitely a GPS is more of an advanced project. It's not the simple things like LEDs or potentiometers or things that is kind of going to work the same for everyone. The GPS can sometimes be a little bit finicky, so I need some feedback from you guys as far as how that is going. Okay, the other thing, we're on lesson 6, and yesterday in lesson number 5, or last week in lesson number 5, I got you guys to the point that on your local GPS that you could read in those NMEA sentences, you could bust them apart, and then you could reach out and grab a couple of useful things and then convert them to Latlon so that you could put those numbers on Google Earth and then you could see where you were. So I wanted to, as quickly as possible, get you to the point that you had something that was kind of rewarding, something fun, like you got yours working where it shows you where you are. So you get a little positive feedback to the old brain there that you got something working. So I kind of did it quickly, and now we got to go back and realize some kind of serious things that we've got to clean up and fix. And those things are associated with challenges that arise when you are reading data from a device like this GPS module that's a UART device that is just spewing data. And that's kind of what I want to show you. I want to show you the challenge associated with that and something that we are going to have to fix here. So what I will need you to do is we're going to go back to where we were with that first program. It wasn't last week, it was the week before that. You can get that program by going to the most excellent www.toptechboy.com. Use this happy little search icon here and search on something like connecting the Adafruit Ultimate GPS to the Raspberry Pi Pico W. You will get this schematic showing you how I have mine hooked up and the connections that will make this little snippet of code work. So we're going to grab that snippet. We are going to come over here to Thani. We're going to paste it in. And in this program, all we're doing is we're just grabbing a character at a time from our UART bus, and we're grabbing a character and printing it. So we say, is there a character there? If it is, we read it, and then we print. So we just do read, print, reprint, reprint. Okay, no problem there. Then last week what we did is we're doing the read, but instead of just read print, we are building a NMEA sentence. And then when we get to the end of the NMEA sentence by seeing the \n character, then we go in and we try to say, okay, what sentence is it? Is there something useful I can do? And we try to start getting some useful data. But even here, we are not dilly-dallying, and all we are doing is we're going in, we're grabbing the data and then grabbing some useful data out of the stream that's coming in. And then immediately we go back and we start trying to read again. So we are just reading, and we only interrupt for a very short period of time to do a quick trying to get some useful data out, okay? But now what I want to do is I want to go back to the earlier simple program that is just reading and printing characters. And so if we run this, what is that? Okay, there it goes. All right, so I'm going to have a sip of coffee. You can see that I have a fix. That's good. And you can see that I'm getting good data. That's good. So everything is great. I'm reading in those characters and I am printing them out. But here is kind of what the challenge that I want you to see is. These GPS modules do not operate in a nice client server type of way, like they're sitting and waiting for you to ask for something and you say, oh, send me lat, and then it sends you lat, or oh, send me lon, and then it sends you lon. No, it is just sitting there and it is just throwing data at you. And I want to kind of illustrate what the problem is. As our program gets more complicated, we might need to go do something else. We might need to go connect to Wi-Fi for some reason. We might need to stop and create a file that we're going to send to Google Earth. We might be needing to do more complicated things, and we can't just sit there and read like we've been doing. So let me kind of illustrate that with a very, very simple example. So we're going to come in before the try, and I'm going to start its timer. So I'm going to say t_start. Make sure that you imported time up here. t_start. And I'm going to say that is going to be equal to time.time, like that. All right, then I'm going to come down here. I have printed the character out, and now I'm just going to kind of randomly come in. I'm going to interrupt the program. So I'm going to say if time.time, that's the present time, minus t_start, if that is greater than 5 seconds, then what do I want to do? I want to print, and I'm going to say delay 5 seconds, like that. Okay, now I'm not talking about that wait that I just did while I was doing, I'm not talking about that 5-second timer I just did, because that was just letting me read and print data for 5 seconds. After reading and printing data for 5 seconds, now I'm going to interrupt the program with that if statement. And now what am I going to do? I'm going to time.sleep for 5 seconds, and then I'm going to reset my timer. t_start is equal to time.time, like that. Okay, so this is going to get 5 seconds of data, then it's going to interrupt, and then it's going to sit and do nothing for 5 seconds, and then it will drop out of this and it will start taking data again. Now, what I want you to sort of see here is in the real life, this 5-second delay would be going out and connecting to the internet or trying to plot a graph or doing this or that. It's going away and doing something, and it's not just sitting and constantly reading. Okay, so with that, let's go ahead and run this. And then I want you to be watching your little shell down here and watch the data coming through. So we're going to run this, and things are running great. Okay, it's like 2, 3, 4, 5. And then here in a minute, you see there's the 5-second delay. So I stopped reading, and I'm waiting 5 seconds. Now I start reading again. I'm going to kind of let it do that 2 or 3 times. Okay, now 5-second delay. All right, so that's twice now I've delayed it. And I'm going to try to let it delay a 3rd time, because I'm trying to see there's sort of like different ways that we can be causing a problem. And I'm going to just sort of let it interrupt a few times to see if we can see the different ways that things can happen. And then we'll stop and talk about it. Okay, so I'm going to stop this here. Now, okay, So here is a 5-second delay, okay? And so now let's go back and let's look for the earlier 5-second delay. And what I should say with these delays is they could delay between the burst of data, right? There's a burst of data, a pause, a burst of data, a pause, and you can see that in the way that those lines are printing out. It could interrupt between the burst of data or in the middle of the burst of data. So I'm going to go back and kind of see where those delays happened. And so you can't just look at the first, you've got to kind of scan the whole set of data because those delays could come in sort of anywhere in there. Okay, so we kind of have something interesting happening there. Okay, this one you can see something unusual is happening there, and we'll have to come back to that in a minute and look at it. Okay, but right now, let's look at this 5-second delay. Okay, let's look at this 5-second delay. Now, you know in those bursts of data, the last NMEA sentence that tends to come out is this GPVTG, and you can see we got a complete GPVTG sentence because we see this A star, like a letter star, a number. So we see that we got the complete NMEA sentence read in, and then we delayed, okay? And after our delay, then we came in and we read the GPGGA NMEA sentence, which tends to be the first sentence in a burst of data. So you would kind of think things look pretty good. We had a burst of data, we paused 5 seconds, and then we read the GPGGA sentence, okay? But this is what I want you to see. Not too much useful information here, but if we look at the GPRMC NMEA sentence, we can see that it was taken exactly at 6 hours Universal Coordinated Time, 15 minutes, and 44 seconds, okay? Then we got another NMEA sentence, which should have taken no time at all, and then we waited 5 seconds. So if we took this one at 44 and we wait 5 seconds and do a little bit more, where do we expect to be? We expect to be at 49 or 50 seconds. But if we look at this next GPGGA sentence after the 5-second delay, it is not at 49 or 50, it is at 45 seconds. So this one's at 44, we wait 5 seconds, and then I'm at 45. We have a what? We have a timing problem, or we just warped through time. We built a time machine because I wait 5 seconds, but only 1 second has elapsed. And so what has happened? And what has happened is kind of the point of this lesson, and it's something that we have to address. And what has happened is you have to realize with your GPS unit, the Raspberry Pi Pico W is not directly reading from the GPS. It is reading from the buffer. Okay, it is reading from the buffer. And so what is the GPS doing? It is cramming data into the buffer. And if the Raspberry Pi Pico W is reading the data out of the buffer, everything is fine. But if you stop reading the buffer to keep it cleared out, this is what happens. The data is coming fast and furious into the buffer on one end, and then on the other end, we're reading it out, okay? But if I stop reading it, what happens? The data is crammed into the buffer, and now the buffer is full, okay? And now I count 1001, 1002, 1003, 1004, 1005. What happens when the buffer is full and I count 5 seconds? Okay, because why is it full? Because I'm not reading it out. I'm not reading it clean. Well, what happens is the incoming data fills the buffer, and then any new incoming data is just lost. It just goes away because the incoming data doesn't overwrite a full buffer. It just sits and the data's thrown away. So what happens? I got this NMEA sentence here, and I read that, let's say this one, I read that out of the buffer. And then this one came in, and I read that out of the buffer. So my buffer should be pretty much empty, right? And then I delay. While I'm delaying, what happens? This comes into the buffer. This comes into the buffer. This comes into the buffer. And then you're going to reach a point that the buffer is full, and then all the data is being thrown away. But at the end of 5 seconds, what am I reading? I am reading that data that went into the buffer during the delay. Now, usually, okay, so why is this serious? This means that if you came in and you parsed this data and you got your lat long from it, it is not at the current time. It is a stale, old position. It is stale and old data, okay? Does that make sense? Now you say 5 seconds, who cares? Well, for some things you do, the delay might be longer than 5 seconds, and it might actually be quite a bit older and staler than this. But even more than that, you have a bigger problem that comes up. And let me see, I might need to get out of your way a little bit more here as we're looking at this. So let's see, this NMEA sentence looks pretty good. It's like I have time, I have lat north, I have lon east, I have a fix, I have 8 satellites, I've got the dilation, I've got my altitude, I've got all this. That's a good NMEA sentence. Then I come up, this one looks good, this one looks good, this one looks good, and now let's look at this one, GPGSV, and let's see if I can see anything unusual there. And actually, you do. Okay, actually you do. Because what do you see here? This is what a GPGSV sentence should look like. So this is a complete sentence. It is old and stale because you can see it came after the 45. And so this, like the 45, is old and stale, okay? And now on your next read, you are getting another GPGSV sentence. You're getting out of a total of 4, you're getting the third one. And you have 13 satellites in view, and now it's telling you about satellite 10 and the strength of 17. Okay, but what happens? This sentence gets chopped off. It doesn't have all of this stuff. It then goes in mid-GPGSV sentence, and it then starts getting a fresh new GPGGA sentence, and that is coming when? At 6 hours, 15 minutes, and 50 seconds. And so this is the first NMEA sentence that has come after the 5-second delay, and it chopped off the GPGSV sentence. So let's see what happened. I interrupted with a 5-second delay, okay? And during that 5 seconds, all of this data to right here came into the buffer, and now the buffer is full. What happened to the last part of the GPGSV? The buffer was full, so that got thrown away. And then no telling how much data got thrown away. And then finally, all of a sudden, out of nowhere, then I start reading the new GPGGA sentence, okay, at the right time. Now, why is this important? I've told you, number one, it is because you're going to think you're getting real-time data, but you're really getting old and stale data, and that can cause some really unusual and bad things. And the other thing is, this is a partial NMEA sentence. And so now if you go in and you try to parse that NMEA sentence using the algorithm that we developed, the program is going to crash. And it's very, very hard to try to write software that could deal with this, where you're trying to handle error exceptions due to trying to parse an incomplete NMEA sentence. Okay, so what does this tell us? This tells us that we cannot leave this UART and this read function unattended. We have to be constantly reading, and if we're going to do a little parsing and a little data formation, it has to be quick. It can't be send something somewhere, wait for something, look for something. It's got to be real quick and get back and do the read again, because you've got to read so quickly that you do not let your buffer overflow. I'll warn you about something else. If you start doing something and it looks like the NMEA sentences are keeping up and everything is good, but imagine if you're keeping up almost, but only 2 or 3 characters you're falling behind on, then it's going to run and it's going to run and it's going to run, but those 2 or 3 characters are going to accumulate, and then at some later time, unexpectedly, it's going to crash, because all of a sudden your little characters that you're not keeping up reading have built up and have filled the buffer, and then you run into this problem again. So you have to make sure that you're keeping that buffer cleaned out. You've got to make sure that you are keeping that buffer read. Okay, so I've shown you the problem. Leave me a comment down below showing me that you understand the problem that we have. So what we did here with this program, yeah, this is a lot of fun. This program's a lot of fun. It's giving us lat, it's giving us lon, it's giving us all of that data. But if we started working with the little OLED screen, or we started doing this, or we started doing that, all of a sudden this code is going to break, because we are reading and doing other things and reading and doing other things. We have to focus solely on reading, or just absolutely minimal parsing of the NMEA sentences. So this is your homework. Your homework is to create a robust solution that will constantly be reading, while at the same time allowing you the opportunity to go do something else. Now, this is an advanced class, so those of you who are taking this class, my assumption is you took my Raspberry Pi Pico W class already. So for you guys, your homework assignment is to go in and fix this problem, where you constantly keep the buffer read out. You keep cleaning the buffer. You're reading it instantly. You're reading it constantly to keep it empty. So you go and you take this code and you rewrite it in a way that that problem is solved. Now, I'll give you a hint, which if you've taken the class, you can already see it. What do you need to do? The Raspberry Pi Pico W has what? 2 cores. You need to do them both. You need to be doing the reading on one core, and you need to be doing everything else on the other core. Now, in the reading one, you could just do very simple parsing, where you kind of take the NMEA sentence apart and get your data structure put together, where you have your useful data, but then you don't want to mess around with anything else. Then you have the main core that you're going to be doing whatever else in. Okay, so I want you to take this program and I want you to go in and redo it using both cores on the Raspberry Pi Pico W. Okay, guys, and if you're just drive-by shooters and just thought a GPS project would be cool, and so you're taking this class without knowing how to do threading and operating with the different cores, never fear. I will show you the solution next week. But if you haven't done threading right now, you don't have the skills to do it. Maybe you could go back over to my Raspberry Pi Pico W class and you could look at the dual core lessons or the threading lessons, and you could do those, and then you would understand how to do this. But for now, today's lesson, what you learned is you learned what the problem is, And now what your homework assignment is to go in and fix the problem. Guys, I hope you're having as much fun taking this class as I am making it. I am really loving playing around with this GPS. Hope you guys are too. Also, it's at this point that I always give a shout out to my Patreons. The only way that I can continue to deliver fresh, new, quality content every single week is with the support of my Patreon. So you guys that are standing with me on Patreon, great big thank you to you. Also, you can help this video by giving it a thumbs up and leaving a comment down below. That will help with the old YouTube juice. If you haven't already, subscribe to the channel. When you do, make sure you ring that bell so you'll get notification when future lessons drop. And most importantly, share this video with other people, because we need more people in the world knowing where they're going and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.